So here the course which we are going to discuss here is DSA with Java. So which is nothing but data structures and algorithms. Data structures and algorithms with Java we are going to see. That means the complete scenarios we are going to implement by using Java programming language. See what content will be there for this. So around we have some 19 to 20 modules are there. Let me give that introduction first. So then we will go in detail. So already I have this content with me. I will copy paste. So I don't want to take much time. Yes, you can see. This is nothing but the syllabus what we have. You can see the first module what we have here is algorithms and analysis of algorithms. Whenever you are developing any program, it is very common requirement to write algorithms. We will write some algorithm, right? So while writing the algorithm, what are all the steps that we have to follow? And every algorithm is associated with some characteristics. So how that characteristics we are going to fulfill. Okay. So even sir algorithms and we are going to see the data structures classification also at very top level. So what is mean by data structure? Why we are using the data structure? Like some theoretical parts we are going to cover. And coming to analysis, sir, for example, if you take any single problem, you will be having multiple solutions for the problem. Example, if you take swapping of two numbers, I want to swap two integer values. Then how many solutions we have? Around five solutions we have. That means I am going to develop how many algorithms? Five algorithms. So I have to analyze these five algorithms and I need to select the best one. So that is called as what? Analysis of algorithms. While analyzing the algorithm, two factors will come into the picture. One is nothing but time and the second one is nothing but space. How much amount each algorithm is going to take, how much amount of time each algorithm is going to take is called as time complexity. How much space it is utilizing is called as space complexity. Those are two things we are going to discuss. This is very first session what we are going to see. After that, recursion and applications. Recursion at very top level. Recursion means what? For example, if you have any method is there, like if you consider void m is nothing but my method, inside that you can take any number of instructions, but somewhere you are going to call the same method. So you will directly invoke this method, and after executing all these things, again the control will be transferred to the same method. Again it will execute, again it will be transferred to here. How many times it will execute? Internally, we are going to write some base condition. Until base condition is satisfied, it will keep on executing. This process is called as recursion, and the method which is invoked in this process is called as recursive method. So, how many different types of recursions are there? How you are going to handle the recursion? For what kind of problems we are going to take recursion? And with multiple examples, around 25 examples I am going to cover for this recursion, starting from low level to moderate level and high level examples will be there here. So after that, there is some algorithms are there like backtracking. So backtracking means what? Whenever you are solving any problem, if you are not getting solution, you can come back and you can search for another path. That is called as backtracking. Generally, chessboard problems and Sudoku problems, rat in math. So sum of subsets, these kind of problems we can solve by using backtracking. Next and after that, divide and conquer. When you have a big problem is there, how you are dividing that big problem into small problems until it can be solvable. And after finding the solution, we will combine to get the original solution. This process is there, right? First, we will perform divide operation. Then after solving, we will combine. That is called as conquer. So merge sort, quick sort, binary search algorithm. These are the best examples for this. Next, what are all the various sorting algorithms? How we can able to sort both normal sorting, customized sorting, and bubble sort, quick sort, selection sort, insertion sort, heap sort we are going to see. And what is mean by searching? We have two types of search are there, right? Linear search and then binary search. How they are going to work internally. And a dynamic programming. See, in the recursion, there is one problem. Here you are going to get more method calls will be there. Okay, you are going to get more method calls. How we are going to reduce that? For that, we will go for DP. In DP also, there are two approaches are there that we are going to see. Minimum 5 to 6 problems I am going to discuss in the class. And a greedy method, which is very important. Here also I am going to take some 5 to 6 algorithms. Hashing means what? How to develop hash algorithms and bit manipulations. How to deal with binary numbers. So whenever you are using binary number concept in your program, your efficiency of the program is going to improve like anything. These are the first 10 topics where I'm going to talk only about algorithms what we have. If you are clear with this, I will go for data structures. Clear up to this? If you have any questions, feel free to ask. Any questions from your end?
No questions.
Right. So coming to data structures, which is very important. See, data structures means it is not storing of data. So some people are going to tell, suppose if my container is there, I want to store my data into this container. This concept is called a data structure. No. When you have some different data are there, whether it may be in database or in your local program, anywhere, some data is there means how you are going to organize, how you are going to organize that data. Sometimes they are going to use FIFO technique, first in, first out. Sometimes they are going to use LIFO technique. Sometimes they are going to use linked list. Sometimes they are going to represent in the form of a tree. Okay. Sometimes they are going to use some kind of a graph. Like there are different ways are there for organizing this data. Those concepts are called as what? Data structures. I think you have aware of these names, like very basic data structure is called as array. Then next we have string data structure is there. I'm not going in detail about these three because in your core Java you have learned all these three things. That's why I'm going to give videos access. So around some 30 hours a session will be there by including all these three concepts. Just whenever you have a time, you need to refer. Okay. Then after that linked list. So I'm going to explain minimum 30 to 40 operations, 50 operations. Some operations I will give it as a homework. And the stack data structure, how it is going to work. Then applications of stack, queue data structures, okay, and applications of that. Then priority queue, how priority queue is going to work. Next, very important. So tree data structures and graph data structure. Minimum some 5 to 6 hours I am going to spend only on tree and some 5 to 6 hours on graph. So the main topics here are nothing but tree data structure. The main concepts here are nothing but tree data structures, graph data structures, and linked list. These are going to have full maza, more number of problems we can solve. Even you can expect these problems in the lead code also. In the lead code also, they are going to give these kind of problems very regularly. So this is nothing but course content what we have. So if you have any questions, please let me know. Then I will start the syllabus. Feel free to ask your questions. Yes, go ahead. Any questions?
Sir, I have one question. So, are we going to see some example problems for all of these concepts, or how is it, sir?
Yes, madam. For everything, we are going to see some example problems. For example, if
Okay,
you see here, there is one concept I explained called backtracking.
okay,
Yesterday we have taken one session for the 7 o'clock. So what is mean by backtracking? So how you are going to get backtracking? What is the previous approach? What problems we are facing in the previous approach? And some
okay,
examples for backtracking. You can see these are the
okay,
examples. So in this we are not going to cover all, but at least maximum pattern wise. So how backtracking will work? Basic by taking one array, I explain. Then n queens problem, something like chessboard problem is there. So I'm going to write code for everything. You can see these are the possible combinations of chessboard. So like that, we are going to explain everything.
okay, okay, sir. Got it.
Any
Thank you very
other questions? Yeah, okay. Any other questions? Yes, please.
So timing will be 7 to.
Yes, timings will be 7 to 8 o'clock morning.
Oh,
Sorry, it is weekend batch, right? So we are going to spend more time. Like sometimes maybe up to 10 also I will take. But Saturdays maximum 2 hours or 1.5 hour session will be there. Sunday compulsory 3 hour session will be there.
okay.
7 to 10. So this is weekend batch. So every Saturday and Sunday sessions will be there at morning 7 a.m. Okay, you plan up to 10 a.m. Don't accommodate with any work. So please put a concentration, take a paper and notebook and pen, sit along with me and practice, because data structures means if you practice more, you can learn more. The only thing is just you need to practice by listening the concepts well. Okay, clear.
much. So, sir, when is the first class starting? Today
Um,
will be
yes.
demo. Yeah.
Actually, generally, demo and then followed by classes will be there. But my nature of taking classes is I'm going to start one topic today itself.
Okay. Okay.
So it is not a kind of demo, it is a regular class only, but you can attend these 2 days without paying the fee. And this concept, whatever I am explaining in the demo, won't be repeated further. It will be continued.
Okay. Okay.
Example, today I am going to start recursion and applications. So
Okay.
today and tomorrow we are going to maximum 70% of the recursion we are going to cover.
Okay.
Rest of the things I will complete in the next weekend. So next weekend onwards, regular class will be there. Regular classes in the sense you will pay the fee and you are going to get a new link. In that link you have to join.
Okay, sir. Okay.
Yeah. Any other questions?
And will these sessions be recorded and given to us, or?
Yes, madam. These sessions are recorded maximum on the same day, like 10 o'clock or 11 o'clock. They are going to upload in a separate folder, and
Okay.
that
Okay.
folder access will be given to you. In that folder, all videos like session 1, session 2, like that, they are going to give. Okay,
Okay, sir.
and
Okay.
make sure those videos are not downloadable. Just you'll be having access for 6 months from the
Hmm.
date of your payment.
Okay. Okay, sir.
And I'm going to share these running notes separately. So that will be for lifetime access.
Okay.
And the videos, whatever I'm sharing resources, these are also lifetime valid.
Okay, sir. Okay, sir. Thank you. Makes
Yes.
sense.
Any other questions?
Sir, what is the duration of the course?
Sir, duration is 5 weekends, not five. It may exceed. So I'm going to plan for 6 or 7 weekends. Don't restrict to the timings, sir. I mean, validity of this course. Just I'm going to give more examples, but max 6 weekends. Okay.
I got it. Sir.
Excluding demos. Don't count the demos into the sessions. Okay. Someone is asking for array string collection along with videos. Material also provided. No. For these, we are not going to give any material. My intention is to you need to watch the video. So sit in your system and in the video, whatever concepts I explain, just you have to practice on your own. Because in all these three things, there won't be that much theory, more practical. If you take array, so how to find length of the array? Array name dot length. Just one definition and how to work with it. What are the various loopholes are there? Around some 15 to 20 minutes I spent only on that finding length of the array. So like that, you need to write the notes for that if you want. Okay, so sir, if everyone clear with the content, I will start today recursion. Clear?
Clear, sir.
Right. So let us go for the first topic, what we called as recursion and its applications. Recursion and its applications. See, let me first come with normal scenario. Then only I can give the full-fledged definition for recursion. Sir, I hope everyone knows a Java program well. Now I'm going to write a simple Java program, how it will be. So you have the knowledge of Java program, right? You can see, sir, this is nothing but a simple Java program skeleton. Sir, if I'm trying to print any message, there is one output statement is there, system.out.println. So, good morning, dear students. Like this, I'm printing some message. So this is nothing but a simple Java program. Let me take 1 minute time to explain this. Sir, every Java program is a completely object-oriented programming. So you need to take compulsory a class, followed by the name of the class is also very, very important for unique identification purpose. So whatever class name that you are giving, it is recommended to save the file with the same class name. Why? Because compilation and execution will become very easy for us. Next, so it is having one special method called main. So because the program execution always starts from main method that we know very well. And here main method is decorated with some special keywords like public, which makes its visibility to access from any system and from anywhere. And one more modifier called static. If you declare any method as a static, without creating object directly we can access. But generally, if you want to access any method in Java, compulsory object must be required. But the main method object is not required, right? That's fine. And main method is taking some parameters. Okay. And SOP, system.out.println. How we are going to execute this program? Sir, I will use different IDEs. At the very beginning for recursion, I'm going to use this command prompt and that edit plus. So how you can compile the program? So I have to move to the location where I saved. Then program is going to be compiled by using javac command, and we can execute the program by using Java. This is nothing but a simple Java program, how we can able to execute. I hope you have already clarity about this execution procedure. No need to give any information. Clear, friends, up to this?
Yes, sir.
Any questions from your end?
No question, sir.
No question, sir.
Right. So now listen. Slowly, I'm going to bring into some concept. Example one. I'm taking one example. Listen carefully. What is the example I'm taking here is, sir, instead of this message, assume I have a message saying main method execution started. Like this, I'm taking. Main method execution ended like this. Now my requirement is, in between this, I'm going to call one method called yum, and that method is there with some information. So what that method contains? System.out.println of. So method yum execution started, method yum execution ended. Like this I have. How the flow of control is going to be happen, I want to analyze. Sir, whatever methodology you know, based on that we can decide what is the output. Sir, the program execution starts from main. It will print main method execution started. Then since we are calling another method, so the control will go to that particular method. And here there are two SOPs are there. Those two SOPs will be printed. Again, it will come back. So after execution of this 11th line, 12th line will be printed. So what is my expected output? Main method execution started is the first line. Method m execution started is the second line. Method m execution ended is the third line. Main method execution is ended. Like that we are going to get. Really, is it happening? Let me cross check. Yes, whatever output I told, same output we got. But internally what happens? That is the part which we are going to learn now. I will take two examples. If we are very clear with those two examples, we can develop multiple applications on the recursion. Sir, up to this, no questions, right? Please confirm. Yes, please. Right. So internally, what happens? Listen carefully. Sir, there is one person with name JVM called Java Virtual Machine. There is separate one person will be there for executing the program. So the name of the person is nothing but JVM, Java Virtual Machine. So what Java Virtual Machine is going to do is, Java Virtual Machine is going to create one stack for every Java program, not only for Java, for any kind of programming language. That virtual machine who is going to execute the program is going to create one special stack. What is this stack? One side open, one side closed. Sir, stack follows one special technique called LIFO. What is the meaning of this? Last in, first out. This is the loophole, or this is nothing but the highlight point to run the methods perfectly or to run the recursion perfectly. Now it is one side open, a blocks will be there like this. A blocks will be there like this. So first, what JVM is going to do? Sir, JVM will create this stack and it assumed that we are going to start the program, and JVM has a very clear instruction saying that the program execution always starts from where? Main. So whenever it is start executing, that main method entry, some logbook will be there, right? There we are going to write entries. In that record, in that stack, JVM is going to write main method because this is the starting point of the execution. Then main method will come into the picture. Sir, it executed first time. Now we are calling another method, right? Now what will happen? Sir, main is navigating its work to some other method. What is that method? Yum. That will be the second entry in the stack. Sir, why? Because when you are going to execute the method yum, again you need to come back, right? How you can come back? It should be somewhere log should be written, right? So from where you are going, you need to come back. So that entry should be written in the stack automatically. Now the control will go to main. Sorry, yeah. It will execute these two lines. Up to this, any questions? Up to this, any questions?
No, sir.
No. Sir, since the method yum execution completed, right, it will delete this entry from the stack and it will come back to the most recent call from where we got this main method. So then main method, is there any pending instruction? Yes. Let's execute this one. So it will delete this main method also and it will give this stack to the JVM saying my program execution completed. So my stack is how you have given the stack. I utilized that stack and I have given that empty stack so that you can use this stack for future purpose. Like that stack will be returned to the JVM. Next time JVM is going to create one more empty stack for the next program execution and so on. Is it clear? This much story is happening in the background. Sir, understood everyone?
Yes, sir.
Clear? Please open your mouth and speak, everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Right. So now what I will do is I'm going to create one more example with multiple methods so that you will get more clarity. Please observe carefully. Now I'm taking example number 2. Sir, what is the second example here we have? Sir, I'm taking one more method. Let it be yum1, method 1, method 1, method 1, yum2, method 2, method 2, and I'm calling method 1. Like this we have. Is how it is going to work. So first I will navigate. So JVM is going to call which method? Main method. JVM is going to call main method. So first entry main will be there here. Observe friends. Then this line will be executed at first. Second, we are navigating to method M1. That entry will be there in the stack. We are navigating to method M1. Now it will execute. One second. Now it will execute this line as the second step. Are we stopping? No, we are navigating to some other method. So that entry also will be there in the stack. Now what will happen? This is nothing but third line. This is nothing but the fourth line. Sir, method M2 completed. Come back. Sir, is it going to coming back to main method or M1? Sir, after completion of method 2, what is the most recent method called M1? You should go to M1, not main. This point is very, very important, friends. Now that M1 method pending instructions will be completed. Now what will happen? Again, who is the caller of M1? Main method. So now it will return back to where main method. Is there any pending instructions? Yes, that will be executed. Now main method will be deleted and it will return to the JVM. So how this stack is created, how it is destroying one by one instructions is our motto of today's class. Any questions from here, friends? Please confirm.
No, sir.
Is it clear for everyone?
Yes, sir.
Yes, sir.
Let me execute this code. Is the expected output is coming or not? Let me cross check. You can see main method execution started. Okay, main method execution started. Next, method M1 execution started. Then method M2 execution started and ended. Then method M1 execution ended. Then main method execution ended. Like that we are getting. Like that we are getting. Okay, sir, clear up to this? Yes, everyone.
Yes, sir.
Now I am going to write some few points. Please listen carefully. These points are very, very important. Now listen carefully. From all these things, sir, can I write a statement like a method can call another method? Am I right, sir? Please confirm. Is it correct?
Yes.
Can I write one more statement like a method can call same method also? No problem. Correct, sir?
Yes, sir.
There is no issue. Sir, in this example, let me take M1 method is there. Okay, M1 method is there. So what I will do is main method is calling that M1 method. M1 method is printing some message called hello. Okay, and the same method again we are calling. It is also a method, right? Then what is the stack? How it is going to run? Sir, JVM is going to call main method. Main method is calling M1 method. M1 method is again calling M1 method. So again this M1 is calling M1 method. This process will never stop. It is keep on executing. Correct, sir? Everyone?
Yes, sir.
Now the question is, sir, JVM is going to request memory manager for getting that stack. JVM won't have any stack. JVM is going to request memory manager, array memory manager, some methods I'm going to execute. The program execution came to my scenario. Can you please give some stack so that which method we have to execute next? I don't remember. If I store it in a stack, easily I can able to execute. Like that, it is going to request memory manager. Memory manager has given some stack. Sir, memory manager won't give a big stack because if it is taking too much time, then it won't be good programming, right? That's why it is going to give with some limited stack. So until that stack is full, you can enjoy. Once if the stack is full, then JVM is going to tell, Arey boss, I can't execute these methods because you are keep on executing. There is no termination. Like that it is going to tell. Now let us execute this code and check what output we are going to get. Please listen carefully. Sir, are you seeing it is keep on printing hello? Sir, up to what? Up to certain level, but you have to analyze what error we are getting at the ending. What error we are getting at the ending. Sir, observe carefully. What is that error? Exception. There is some runtime error. It is unexpected. That's why runtime error in the thread main while executing the main thread, unexpected error came. What is that error? Java.lang. What is this error? Stack overflow error. Sir, in my program, I never used stack. Now, this shows a proof that JVM is internally using a stack. So that stack got overflow. How I can able to execute? Like that we are getting some message. Okay. So I hope you are very clear with the program. If you are clear with the program, I will write some points related to this. Clear?
Yes, sir.
Right. So this is nothing but example program to demonstrate this. Now, so we know that a method can call another method. That method can be same method. Now listen carefully. So a method which is called by same method is called as recursion. Same method. This process this process is called as recursion, and the method which is invoked in this process is called as recursive method. And on a special note, sir, recursive method or recursion always leads to infinite execution, or I can use the word called stack overflow. Sir, how to stop? If we want to stop this process explicitly, we have to supply some special condition, sir, called as base condition. What is that condition? That special condition is called as what? Base condition. Sir, how you can do that? Don't worry, I will explain again with the program and the demo. Are you clear with the 3 points, whatever I have covered now? Please confirm.
Yes, sir.
Yes, sir.
Clear, guys?
Yes, sir.
Yes, sir.
Now listen carefully.
Yes, sir.
So, what is the next thing is going to be happened here is, listen carefully. Sir, I'm going to give some parameter. Array, how many times you need to print this hello? Sir, I want to print this hello for 4 times. Sir, it is an integer value, right? You have to receive that as one parameter. Yeah. After printing hello, sir, you can call for n minus 1. Sir, one more diagram will come into the picture here. Observe carefully. We are calling a method by passing input as the 4. Now what will happen? Sir, we are printing some message called hello here. After printing this message, again I am calling for m of 4 minus 1, which is nothing but 3. Now again it is a method, right? It will print a message called hello. Again it is going to call for method of 2. Sir, again it will print for hello. So it will be called for m of 1. like that. Sir, now what will happen? Again, it is a method, right? So it will be called for hello. It will print hello. So again, it is going to call for m of 0. Sir, one time, two times, three times, four times. My requirement completed. Why can't we stop when m is equal to 0? I want to stop. In recursion, if you want to stop, there is one special keyword is there called return. So I will write that condition at very beginning. Array, you are giving n value. Suppose if n is 0, I will stop. Otherwise, you can go execution. That's all, friends. Are you clear with this code?
Yes, sir.
Yes, sir.
Now the question comes, sir, who is going to remember that n value every time? Because every time it is keep on changing, right? Who is going to keeping the track of that? Sir, that will be stored inside style. First, you are calling main method. Main method is calling, sir, some method with parameter 4. This method is calling another method. Here it is same method with value as a 3. It will be called with a value as a 2. It will be called with a value as a 1. Now this will be called with a value 0. Now here the program execution stops, right? Here the program execution stops, right? Now what will happen? So there is nothing to execute. It will delete all these entries while coming back. It will delete all these entries while coming back and it will return to the JVM. Sir, any questions from this? Is this concept is clear for everyone?
Yes, sir.
Yes, sir.
So now let's check, is it getting infinite recursion or not? Now we will get clarity. Sir, is it infinite recursion is coming? No, sir. How many times it is executing? Sir, it is executing only 4 times. It is executing only 4 times. Sir. So I can say perfectly our recursion is working. Any questions from your end?
No, sir.
So now you got clarity internally how much story is there on the backside of recursion. Correct?
Yes.
Sir, trust me, if you understand this, everything will become very easy. Now there are few more points are there, or I can say that there are some cases are there. Let me explain those cases, then we can go for uh, applications one by one. Can I? Can I start explaining the applications one by one?
Yes.
Yes, sir.
Right. So before that, there are some 3 cases are there. So let us explain those 3 cases. Then I will. Sir, what are those 3 cases here? Is listen. Sir, first thing, case 1. What is the first case? Sir, based on method calls, based on number of method calls, based on number of method calls. Sir, we have the following types of recursion. So what is the first one? The first one is called as finite recursion. Okay, second one is called as what? Infinite recursion. So if you have more method calls, keep on calling, then it is infinite. I can say it is without base condition. Without base condition. And finite recursion means what? With base condition. With base condition. I hope I covered both these two types in our previous examples. Sir, clear?
Yes,
Yes.
sir.
Next, what is the second case here is very important. Sir, based on number of methods, not method calls, based on number of methods. Sir, we have two types. We have two types of recursion. What is the first one? The first one is called as direct recursion. Second one is called as indirect recursion. Don't worry, examples we will see later. But as of now, see, direct recursion means what? Suppose if I have a method m is there, so inside these we have some group of statements are there. Again, I am calling the same method. This is nothing but a direct recursion. Indirect recursion means what? I have some method is there. Inside these, a group of instructions. A group of instructions I have. After that, I am calling another method. So what that M2 method content is, that M2 method is executing some two lines. Again, it is calling M1. Now you can see M1 is calling M2, M2 is calling M1. Again, it is keep on rotating like this. There is no ending process. So this kind of things are called as what? Direct recursion, indirect recursion. Are you clear, friends?
Yes. Sir, in this case, which one is the recursive method then? M1 or M2?
Both M1 and M2 both are recursive. Why? Because M1 is calling. If you see diagrammatically, this is M1, this is M2. Sir, M1 is calling M2. If M2 is calling same M2, then it is direct. But M2 is calling M1. Again in M1, again it is calling M2. So two methods are invoking in this process, but the process is same. Sir, where we have to write base condition? In both M1 and M2, in both cases, you have to write the base condition. Got it?
Yes.
Clear, everyone?
Yes, sir.
Now, so coming to the third case. So, what is the third case here is case 3. Case 3. Sir, what is the third case? Third case is very simple, but it is very hard to understand. What is the third case here is based on, sir, based on the position of, based on the position of recursive call, based on the position of recursive call. Okay, so recursion is divided. Recursion is divided into two types. What are those two types? The first one is very important, tail recursion. Second one is non-tail recursion. Non-tail recursion. Sir, non-tail recursion, we are going to cover maybe one or two examples in this recursion, in this particular session. But non-tail recursion is called as what? Backtracking. So I told there is one separate chapter is there called backtracking, right? There we are using non-tail regression. And even in the tree graph data structures, we will use non-tail regression. You will came to know how it is that. So first let me demonstrate tail recursion. Sir, to understand the tail recursion very well, I am going to take one special statement like the given number. The given number is nothing but plus m. Just the same program, sir. I am trying to print the number. Let it be m. I don't want to create confusion. Now listen. Sir, what will happen? Let me draw the diagram first. Sir, what will happen? First, we are calling m by passing input as the 4. Sir, what it is printing? It is printing the given number is nothing but n. What is n value? 4. Then it is calling same method by passing n minus 1. Now what will happen? It will print the given number as the 3 and it is going to call the same method by passing 2. Now it is going to print the number 2 and it is calling this another method by passing input as a 1. Now it is calling number 1 and it is going to invoke the method 0. And whenever 0 came, we stop. So what is the output you will get? Sir, number 4 and followed by 3 and followed by 2 and followed by 1. This is nothing but expected output. For what recursion? Tail recursion. Are you clear, friends?
Yes, sir.
Yes, sir.
Yes, sir.
So what will be the stack? Inside the stack, so I'm not writing the main method. First main method is going to call a method with input as a 4 and it will be called a method with input as a 3. Then it is going to call indirectly a method with input as the 2. Then it is going to call a method with input as a 1. Then whenever a method with parameter 0 came, it is stopping. What will be the directions on this side? It will be like this. Clear?
Yes.
Now let us copy paste this because we have seen the output also. Output is executed. Let us execute. You can see we are getting this order. Please remember this order. Now I am going to talk about non-tail recursion. Sir, non-tail recursion means, let me define tail recursion first. So after recursive call, if we are not taking any Java statements, so then it is called as tail recursion. It is called as tail recursion. Sir, what about non-tail? What about non-tail? What is non-tail? Sir, after recursive call, I will take the statement. This is called as what? Non-tail. Let me rewrite the definition. So after recursive call, if we are taking any Java statements, then it is called as what type of recursion? Non-tail recursion. Now definitely there is a change in the output, but how it is going to work? Let me cross check. Can I go for explanation? Please confirm.
Yes, sir.
Sir, when you say statements, you're saying print statements or what? What do you say?
It can be
Okay.
Java, it can be any Java statement.
Okay.
Sometimes it can be method call also.
Okay.
Anything.
Okay.
Right. And now see, so I don't want to erase this stack. Let it be same as it is. So now I am just erasing this tree and I will use different color for differentiation. And let us take this output as it is because we need to compare now. Now, sir, first we are going to call a method by taking the parameter as 4. Now see what will happen. Sir, what is the first line it will execute? It is redirecting to some other method called 3. Okay, correct? Huh?
Yes, sir.
Now it is redirecting to some other method called 2. 1 second. Right. Now it is going to call another method called method with parameter 1. Now it will call another method with parameter 0. Sir, whenever 0 came, it will stop. Am I right, sir? Everyone?
Yes, sir.
Everyone clear up to this?
Yes.
Now, very, very important. So please see the diagram with red color. Sir, m of 0 completed, right? It will delete this entry and it will come back. While coming back, is there any pending instruction is there? 8th line is pending, correct? Now, it will
Sir.
print the number. What is the number that it has to be printed? At this line, what is the number for n? 1. It will print number 1. And it will delete this entry and it will come back. Here, is there any pending instruction? Yes. That number 2 will be printed and it will delete this instruction and it will come back and it will print number 3 here and it will delete this instruction and come back. It will print number 4 here. Now, what is the expected output for this? In this order, it is printing, right? So, number 1 and then 2 and then 3 and then 4. This is nothing but output what you will get for non-tail recursion. Clear? So majority of the students are going to feel like whenever we are using recursion, inside that if we are writing a written statement, completely it will come out from that method. No, it won't completely come out. While coming out, it will check after recursive call, is there any instruction? If there is any instruction, that will be executed, right? Because it is a valid Java. If it is not allowing, it should raise a compile time error or runtime error. But it is allowing us to write. This is a special scenario where you can solve majority of the computer science real-time problems. Clear? Please confirm, everyone.
Yes, sir.
Yes, sir.
Sir, can you
Hmm.
explain one more time? For example, when you said when it is going to be m of 0, it is going to return. But how does it?
If it is returned, the program execution stopped. Correct, Amma?
Yeah, correct.
But if you see, we never executed this 8th line, right?
Yes.
When it will get a chance? After this method, is there any instruction? Yes.
Oh, okay, okay.
When it is keep on going towards down, when it is coming back, it will execute. But in our previous program, there is no instruction. That's why you are not getting any answer.
Okay, okay. So, okay, okay.
Understood?
Yeah.
Let me run this code and check really whether we are getting the expected output or not. Sir, please tell me, is the expected output came? Everyone.
Yes, sir.
So now you got the clarity. What is the difference between tail recursion and non-tail recursion? But don't worry, when we should go for tail and non-tail, once if you see multiple examples, you will get clarity. As of now, clear, right? Clear.
Yes, sir.
Yes, sir.
Right. Let me copy paste this. Now let us see one small two note points I want to cover. With that I will conclude. What is the first note here is, sir, if you see the diagram, you can see the output, sir. Can I say, if you want to print anything, if you want to print in forward or reverse direction, happily we should go for recursion, correct? Am I right? Because n is equal to 4 I have given, I got both in reverse direction 4 3 2 1 and also forward direction. We can take recursion. It can be a stack, it can be a queue, it can be a string, it can be an array, it can be a number, it can be a linked list, anything. If you want reverse or if you want forward direction, blindly you can use recursion. Only that statements you have to adjust. Don't worry, that we have that application also. Clear? Clear, friends?
Yes, sir.
Next, second, very important, most important. So majority of students are having this doubt in their mind. Sir, for what kind of problems I should go for recursion? Can you please tell me? As of now, don't get any confusion. Listen carefully. Sir, I want to calculate sum of n natural numbers. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus and so on plus n. This is nothing but the formula. If you observe carefully, is the formula is x plus y. That's all right. If you take here 1 plus 2, whatever result you are getting, you are adding with 3 again. Whatever result you are getting, you are adding with 4. Whatever result you are getting, you are adding with 5. Whatever result you are getting, you are adding with 6. Sir, there is no new job. Only the existing job we are repeating. That's all. Sir, am I right? Correct?
Yes, sir.
Yes, sir.
Sir, I have some numbers are there, something like this. Okay, I have some numbers are there. I want to sort this. I first sort first two. Arrange those two in the order. Then sort with the third number. What will happen? Sir, 9, 10, 12. Then sort with fourth number. Sir, 9, 10, 12, 13. Sorting means what? Comparing every time two numbers only. This is the common process, but repeatedly you have to do. So, if the problem contains, repeated activities, okay, so then we should go for recursion. You need to identify such a type of things, then only you can. This is nothing but what we have. Any questions from your end? Everyone?
Any questions?
Clear, buddies? Please confirm.
Right, sir.
Yes.
Yes.
That's all. With this, I'm going to stop today's session. Tomorrow, you can attend the same link, same timings. Tomorrow, we have 2 hours session will be there. Tomorrow, we have 2 hours session will be there, 7 to 9. With this theory part completed, I'm going to start explaining some applications, some low-level applications to step by step. I will bring first small programs. Maybe you have already studied those small programs, then a big programs like that I will cover. And at last, I want to give some 2 important conclusions. One is, what is the difference between loop and recursion? When we have to use loop, when we have to use recursion. That is one conclusion. Another conclusion, sir, for what kind of problems you have applied this, I know very well. But is there any problems with recursion? Like that, there is one more conclusion. These two I will explain at the ending. Okay? Clear?
Yes, sir, clear.
Any other questions from your end regarding the course or content? If everything is clear, happily we can leave. Clear?
Yes, sir, very
Okay.
clear.
Sir, you said regarding for that RAS, your 30 set of video, 30 hours of video, no? So next week we will get, no?
Depending on the situation, sir. Why? Because until covering the algorithms, I won't give that. Why? Because he should focus only on these algorithms.
Okay.
After completion of this, so whenever I'm going to start a linked list, at the time I'm going to share.
Okay. Thank you, sir.
I will give some time also for revising that. Okay.
Okay.
Clear, guys? And
Yes.
listen, if you focus more, if you interact more, if you ask more questions, I am ready to deliver more examples. Okay. Sometimes I will take the problems from leak code also, and I will solve that. Okay.
Okay, sir.
Yeah.
Okay.
Right, friends. Thank you. We will meet for the continuation tomorrow.
Thank you, sir.
Thank